would say about my talks is more cowbell. So now I've got that. Cool. All right, so the future. Actually, this isn't even future anymore. This is here, but it's probably future for you because I know everyone's going to run home and download this today. Or you're using it already in your work and you're happy. No?
No, I'm no longer working at the company.
All right, well, see, then you got a little bit of time. Yeah, great skill. You know how many people say, do you know how many Cassandra engineers are?
I haven't really. Actually, I did see one job posting where they were looking for Cassandra.
It's out there quite a bit. We're seeing it all over the place. Hey, is Walmart hiring for Cassandra engineers? Every day, right? So, what we've been talking about is more generalized Cassandra. So what I want to talk about is our latest release, which is Cassandra 1.2, which I think should have been 2.0, but I lost it. So what, we give these version numbers, but really what we're trying to do is we're trying to do about every 6 months a release in the Cassandra world. And then there's incremental releases, major release every 6 months. Cassandra 1.2, which was released in January, beginning of January, has a lot of really, really cool features. And so I'm going to go over a few of these. So the first one is collections. So collections, it means like real data structures, map sets and lists that you can store as column values. So you have a column name and then the value is going to be a collection. I'll talk about this a bit more in the driver part of this, but this is huge. This is really going to make data modeling a lot easier in a lot of ways, especially when you have something like a list, that has order. So that's going to be a good thing for programmers, and I've already got people doing interesting projects with that right now, and I expect to see a lot more of that. The second thing is virtual nodes. Now, at first, that sounds like if you're not really an avid Cassandra user, you really wouldn't care too much about virtual nodes. But what this does, and I'm going to point this out a little more, is this really changes the fundamental operations of how we work with Cassandra. I'll go into detail. The query profiler. If you're writing a lot of code against Cassandra and you're trying to figure out what's fast and what isn't, it's kind of hard to figure out what it is. Not anymore. Now we have a really in-depth query profiler. I got a demo of that. Atomic batches. Not async, but it's pretty close. Meaning that if you throw a batch of mutations at a Cassandra node, it's going to finish it. That is atomic operation. So, and if it doesn't finish it, it's going to store it until it finishes it. And then if it can't do it all, then it's going to error the whole thing out. So this is actually one of the features that was driven by one of our users. They said, we have to have this. And so they helped us in the Cassandra community build this feature. A lot of what you see in Cassandra, and by the way, if anybody wants to see what's happening right now with Cassandra, go to Jira, jira.apache.org. Look up the Cassandra project. Everything is there. We do everything in the open. So if you want to see the current tickets, what people are talking about, what people are arguing about, why or how atomic batches is exactly done and why and all the decisions that were led up to it, it's all in there. We are completely open. If you want to submit a patch, go ahead. If you have a feature that you think should be in there, create a Jira. If you find a bug, create a Jira. It's all about participation. And you'll see that a lot of what's going on in Jira, yeah.
So I'm sorry, atomic batches, that's basically inserts. Is there anything else more than that?
Well, inserts, updates. Yeah.
Oh, okay, updates.
Yep. And anything that you put at as a batch, I mean, here's a bunch of stuff, do this at one time. All right, so anyway, if you feel like participating, go for it. We love participation. All these features probably were from like somebody using Cassandra pretty happy. The JBOD support, basically we're talking about larger disks. We like to put a lot of data on disk if we can. This enables us to put even more data. Meaning with JBOD support, that means that you can have arrays of disks not structured in any way like with RAID or anything, and it actually supports that model pretty well. It balances the data across multiple disks. finally got our CQL transport going. No thrift, sort of. There's thrift there, but you can turn on the native binary. Parallel level compactions, which is a background process. If you know what compactions are, this is important. And then off-heat bloom filters, which really is more about memory management. You can put way more data on one node. So that's the bottom ones I'm not going to go over in depth, but I will go over the top ones pretty deep. And my buddy Merv, he put out something. This is pretty recent, and he was at the Amazon conference, and he was just like, I hear all this buzz about Cassandra. It's true, because you talk to a lot of those Amazon presentations were about how people were using Cassandra, like Netflix, which is pretty cool. Okay, so collections. This is a little more in-depth. Of course, whenever you want to use collections, you have to use our driver, which I'll talk about. But this is basically what you're doing is when you want like a set of emails, like a list or a set or a list or a map, then you can create a set and then you give it a type text. And so when you set that into the database, you can give it a set, like just a Java set. But then whenever you want to update one item, you can update one item inside the set. If you want to get one item inside that set, you can also get one item in that set. We have a whole blog post about how to use them. This is a very useful data modeling technique. This gives you some dimensionality to your data. All right. I think this crowd, since you're kind of new to this, you're like, wow, this could be cool. Now, thank you for the beer. What we have here is similar to what there was, what is it, MySQL, the slow request log, I guess, trace logs. This is similar to that. But one of the harder problems to solve with the distributed system is what happened where and why. And request tracing is something that you can now get out of Cassandra. So in this example, we turned tracing on, and we inserted some data into this test, and here's the two values. Well, when we run the trace, we get to see exactly what happens. But what you see here is kind of interesting and actually pretty cool, is that not only are you seeing what server in the cluster ran it, you also get the elapsed time in milliseconds. But what you see here is now it jumped, received a message from 127.0.0 to 127.0.0.1, so it's actually showing you the trace across the cluster. So if this thing got to this point and had to finish the request on another server, that part right there is really hard to trace in a distributed system. That is now available on traces. This sometimes can be the problem, and you don't even know why. What happened? What server had this problem? Well, this is where it comes back. It took a long time. If you look at the difference between how long it took to get there, oh, wait a minute, we might have a communication problem between these two nodes here. So this request tracing is really going to enable a lot more cool stuff. And this is what's available on that too. So whenever you're writing your application, this is just going to be, I think, just a standard. This has to be a standard tool for whenever you're writing an application. You need to diagnose your performance.
How bad is it to leave it on?
It's on all the time anyway. Yeah. 24 hours. It stores over 24 hours. There's actually a TTL step on all of these.
So the tracing on is really just a show.
This is in the CQL shell. This is our command line tool. The tracing itself, you can turn that on with our driver as well. But you can request to get the trace at any point. This is just the verbose output from the shell. You wouldn't get this every time you do a recourse.
Can the TDL be changed? So instead of 24 hours, can it be changed to a week?
I don't think so. I don't think so. That's a good question.
Maybe you could pipe it into a log.
Well, it's going into a column family in Cassandra. And each node stores its own data about, it creates a UUID for every event that goes on and it links those together. So as this request goes through, it knows this request went here to here, so that's how it knows how it goes through the cluster. Good for things like trying to figure out what node got that data and which one, like if you have a slow node or something like that. Massively distributed systems need something like this. But what's going to open up is whenever we have our development tooling around this, it's going to make it easier for developers to write code. Because actually, one of the things that I found out, one of the things I found out is this is really a cool way to figure out how Cassandra works. Like, just walking through this, it's like debugging code, hitting F5, F5. Oh, this is how they did it. Okay, cool. Well, this is like F5 for your whole cluster. You can actually see how everything is done. I mean, you can see like executing the CQL query, parsing the statement, preparing the statement, planning the replicas for mutation. Ah, found the replica. Now I'm sending mutation. If it was multiple mutations, like if you're doing a quorum read, you'll see it go to multiple nodes. And you're going to see it all in action, right? This is like, ooh, this is how it's all done. It's like going to the back of where the wizard is. Pay no mind to the man behind the curtain. So virtual nodes. Okay, why is this cool? So when you put out a 1.1 node, which you can do right now if you want to, you have to assign tokens to every node. This is one of the operations things that requires a little bit of foresight, a little thinking, and not a lot of people are excited about creating tokens for, they have to manually assign tokens, which are just a way to set up your ring so it's nice and balanced. I'm not going to go into a whole lot more detail in there because I don't want anyone in here thinking this is cool. Because they're not. And this is one of the things I've always hated about working with Cassandra. It's just, why do we still have to create tokens? The original Dynamo paper had this concept of virtual nodes. Finally got it in Cassandra. And so what that means is that one physical server, one piece of hardware, now has little individual nodes of slices of data. Tiny ones, 256 by default. I have a whole webinar on how this works if you guys want to see this on datastax.com. But just in a nutshell, what this enables is whenever you're moving data, like you're adding a new node or removing a node, when you're doing that linear scaling, adding a node for more capacity, these little nodes that are inside of the big piece of hardware make it easier for it to do repairs and adding, because you're parallel streaming all this data from all these different points. So as a result, adding new nodes into your cluster in real time is pretty real. You can do that now. I mean, it's fast operation. The other thing is, before it was hard because if you had a ring and with all your tokens arranged and you had it balanced just right, and then you go and throw another one in there, and then you had to rebalance everything to make it just right. And that was not everyone's favorite trick. Has anyone done a rebalance? See, no one was doing that. So with virtual nodes, just add a new node and it'll sort out all the ranging for you. So just add one node, 2 nodes, 3 nodes, whatever capacity you need. No rebalance at all.
So it's all self-tuning then?
Yes. Self-balancing. That's really a critical part of making sure that your nodes aren't overloaded with data.
Heterogeneous nodes.
Heterogeneous nodes? What do you mean?
Different hardware.
Yes, that's a good point. Notice how this one has a ton of virtual nodes and this one has a few. There you go. I think this is probably one of the things that makes virtual nodes very interesting is now with Cassandra's been out for a while and hardware is starting to rev up. We're going to rev this next generation. This is going to give us a leg up because you're going to have a lot of older hardware with newer hardware. I'll put a lot more virtual nodes on newer hardware and leave the older hardware with less so that it has less responsibility for how much data it has. So the timing is good.
Is there a way to pick how many virtual nodes to put on the node?
I haven't figured it out yet. I'll let you know. There's not a set formula yet. Although I'm pretty impressed at how much data I can put on a virtual node system. I ran a stress test on a single node for 3 days, just pumping as much data as it could take for 3 days. I couldn't bring it down.
So do you have any kind of control over which virtual nodes actually go where to try to maybe maintain a sparse or then
That's what's built into how the system works. The partitioner, which is how the data is separated and how the randomizer works. Partitioner is usually some sort of hash routine. So in pre-1.2 it was MD5, and in the new partitioner for 1.2 is murmur, which is really just a hashing technique. But that hash is guaranteed to be random, and right, if there's any methods in here, you're going to throw something at me, but also unique. Pretty unique. So then whenever you hash anything, you get a 120-bit number out of it, which is random.
But what about also, let's say, even geographical location? So for instance, I'm comparing what I saw recently in the presentation on Spec, for instance, where we have nodes at in let's say, different data centers, you want the data as close as possible. So Ceph allows you to actually assign a higher priority over making sure that at least one of those nodes is close to where your data needs to be accessed. If Cassandra is distributed across multiple data centers, for instance, what is the assurance that you're going to have data that's close to where you really need it?
Good question, and it all comes down to how you assign the replication factors. So Cassandra at its base is replication is based on data center awareness. So it knows I'm in one data center or another. And when you set a replication factor of 3, it's going to put 3 copies in one data center and 3 copies in the other data center. The locality is in the data center. So from a client standpoint, you make requests to a data center's cluster of nodes. And there's different techniques on how to get that locality, and it's all the consistency level. If you're doing what's called a local quorum, you're only asking the ones in that local data center for its data. And since we're replicating at 100% across the WAN, there's no locality issues where it has to cross the WAN link to go find that data. Unless there's an outage, and then it has to go find it. But the locality issues are just covered in the way that replication works in example. Okay, virtual nodes, totally cool. Okay, so, oh, that's the wrong slide. It should be but a driver ain't one. Okay, anyway, so thank you, Jay-Z. So, if you notice I switched colors, because this is a completely different presentation, but I glued it on the end because this is a Java users group. And I have not talked about our new drivers yet. They just went into beta last week, or the week before. So I want to talk about these. They're very cool. They're going to make your Java life with Cassandra a lot cooler. Before we get to this, right now there's 2 main Java clients. There's Hector and Astyanax. Both of those are Greek tragedy characters. So, unfortunately, Cassandra being Greek, everybody got on the bandwagon and said, hey, you know, it'd be cool if we just created all these Greek names, and now the rest of us have to learn how to pronounce these things. When Astyanax came out, I was like,
Asterisks.
yeah, asterisk. I thought asterisk, and like, no, it's not asterisk. It's, I don't know. But anyway, after hearing it 100 times, Astyanax. Why? And then they all have some sort of relevance. Like Astyanax was the slayer of Hector or something, you know, and Cassandra was the harbinger of doom for the Oracle. It's really crazy Greek tragedy. So anyway, we just call ours a driver. We don't have a name for it, and we're not going to give it a name. So our Java driver is new, and a lot of it comes from the drivers that were built for Cassandra were all in community. They were not part of DataStax. DataStax is a company that supports Cassandra and DataStax Enterprise. We needed to be a little more in control of that because our enterprise customers are asking for not only support on running their cluster, but how to use it and support and program against it. And it really comes down to, we just need to be able to have something that is cohesive and tracks with what our direction is because we have a committer. So working on Cassandra, we need to track with the drivers because they have to be working together. So what about our Java driver? If you've used any of the previous drivers, this is going to be a godsend. You're going to love this. If you haven't, you're going to be like, wow, those are great ideas. And of course the driver should have that. So what we're doing with our driver, we're adding a few things. So asynchronous queries. If you're working with a distributed database and the nodes all have different parts of your data, you should be able to make parallel queries against all of those nodes at once for different parts of the data. And you should be able to get all of that data back coordinated. That is what asynchronous queries are about. If you ever heard of Oracle Futures, this is that done correctly because we actually have a distributed system, not just one taking multiple requests. So this is absolutely done through Netty, non-blocking I/O. It is really cool. No discovery, failover, load balancing. If you're going to be working with Cassandra, you're going to want to make sure that your application is online all the time because your database is really trying hard. So if your application isn't trying as hard, then you kind of found your fail point. So there's some really nice built-in tooling and policies and things you can implement directly in how you set up your cluster for things like node discovery. How do you know how many nodes you have? If you're adding nodes and subtracting nodes, how does it keep up with that? failover. If you have nodes going out, how do you make sure that your application doesn't flip out whenever a node disappears? That's a big thing, right? Because we say you could lose a node at any time, your data's cool. Let's make sure the application is cool. And the load balancing. How do you avoid things like hotspots? And that's usually not that big of a trick, but you'd be surprised. The API. Ascianics went a good way of making a usable API. Hector, not so much. I think a lot of Hector, it was built around Thrift, and so it was hard to express that in some sort of Java language that was usable. It's very hard to work with. That's much easier to work with, and I'm going to show you some examples. And we have good documentation too. Our documentation team is really working hard at making sure that it's very usable. So let's do something here. Hey, look, real code. All right, so Java user group. Here's some Java. So let's create a cluster. Cluster, use a cluster builder. Hey, here's all my servers. Go ahead and build that. Now you have a cluster. You can operate against that cluster. So I'm going to connect to this key space. There it is. I have a session. Now I can execute things in the session. So I'm just going to execute the CQL. Whenever I did the session execute on this insert into, I just put data into my database. Very simple API. Now, if you've never used any of the other APIs, you'd be like, of course that's simple. That's the way it should work. Great. Is this better than Cassandra?
I think you skipped a step there.
What's that?
Setting up the key space.
Oh, well, it's already set up.
Oh, okay.
Edge if you will.
That's what I did.
What's that?
It was the first session.
Yeah, it was up there.
These aren't videos.
Man, everyone's a critic. So reading data. All right, should I create the table first? I'll walk through that. All right, make sure everything's pure for you. All right, so result sets. Just say session execute. I want to do a select off of that, and then whatever I say, give me everything and put it into a list. Now it's usable. I can iterate. I can just use iterators to go over it. It is so much easier to work with, and I get my column names directly out of that. Very easy operating API. So here's the cool stuff, the asynchronous reading. So you could set up a result set in future, which, because we're using asynchronous I/O, and we have multiple nodes out there that have different sets of data, you can get away with this. Let's say you have a 50-node cluster out there. You have a 20-node cluster. Chances are that data is distributed over that 20-node cluster pretty evenly. Well, whenever you say select star from user, you're getting everything. So instead of going to one node and saying get everything, you could use this future.get. This is going to actually set up the situation where you're going to be doing all these executions in parallel across your cluster. Every node is going to be participating in this. So the slowest results that you'll go back is just your slowest node. You're probably going to get things back pretty fast because every one of them is going to be executing at their own speed. Instead of lined up like someone in a queue waiting for a bus, you're getting all that parallel data. So you do a future.get, that actually executes this. It goes right into your result set once all of this is pulled in, which hopefully is going to be a few milliseconds for God knows how much data. And then you're iterating again, just like you were before.
So it's not a pure async, like it's not a callback model or something.
It is. It's netty. It's asynchronous I/O. Because what it's doing is it's creating a thread for each one of these and a dispatcher going to each different node. So these are all working asynchronously.
But from the client's perspective, that's still waiting on that.
The last one, right? But if you were if you did this with the previous driver, you would put all of it in a single queue. You would say, here, go get all this, and it would go to one node and come back one at a time. When you do it like this, you're fanning it out over all your nodes, which is going to be a lot faster. That's the difference. And you're doing it, each one of those nodes is being communicated with independently.
I get a question.
Yeah.
I'm actually not the Java guy here, but on that iteration there, like you could have, if there was one slow node, it would run that for block would run, a dozen times for the couple of nodes that aren't slow, and then maybe wait 5 seconds and then run another 5 times for that last node or something.
It's non-blocking until you get to here, and then it's blocked.
Okay, I get it.
this can be run early on in your code too. If you know you're going to need some data, you run this the first line, do some other things, maybe you get one other thing, and then or set up more asynchronous reads, and then down here you do your work.
Okay, that's pretty cool.
Yeah, I told you. And the first time I saw this, I was like, no. And that's all I said. And then they're like, okay, there it is.
It would be really cool if you can register a callback from the client side. So you just make the get and then I do whatever I want and then it calls me back.
We do have a callback interface. Yeah. There's really, all right, so last week I spent a few hours working with the guy who's the head of our drivers at DataStax. And he's this real excitable French guy, and he's awesome. And he is passionate about this stuff. He loves this. And I spent over 2 hours, probably 3 hours, I think, close to 3 hours with him. And I was just like this the whole time. Because it's just so much good stuff coming out of this. And the benefit is we've already had drivers working with Cassandra for years. And it's like we get to learn from all their mistakes and say, okay, thanks guys. Awesome, now we're gonna make it right. And so we get the chance to do it right the second time. And so the API spec is in final beta. If you wanna go check this out right now, it's on GitHub, DataStax, GitHub. You can download the code, you can look at it, you can check out the API. If you wanna go to Jira, the Jira's on our GitHub account. But if you wanna look at it and say, you know what, that API is wrong, say, hey, well, listen. We want to make sure it's right the first time. Okay. Now, another thing, you guys want to do this. Mapping, JPA style mapping. I want to say JPA-ish, because I mean, JPA is all about relations, and there's no relations. But JPA is this. We get this quite a bit. You know, we want to be able to create these persistence models. So what we've done is we've created this JPA-ish type model, but it matches more with Cassandra, which means we're mapping objects into Cassandra. And we've used annotations, and it actually works pretty well. There's some components we've added that are specific to Cassandra that doesn't make it exactly JPA. But let me give you an example. Object mapping. So I use annotations to say which table this user goes to. I give it a partition key, that's obviously very Cassandra, and I tell what column, and if it's a column name that already exists inside the schema, it can do that. And so that whenever I create enumerations, I can put in all my enumeration values that are stored in the database. So this is a great way of persisting objects into Cassandra directly through Java. So the inheritance, it even does inheritance as well. So if you have an inheritance class that you extend, that's doable. Now you can use your Java code and put all your inheritance directly in Java that maps into a Cassandra object or Cassandra table, column family. So I use table and column family. So this is all built into the driver as well. So we have Java drivers out there right now. We have a .NET driver for those of you in that kind of pain. I just kidding. .NET's actually pretty cool. It's too bad it only runs on Microsoft. I actually like .NET. CLI is a lot cleaner, and it's really close to Java. But it only runs on Microsoft. So anyway,
So yours only runs on Microsoft because actually there is Mono.
Yeah, Mono. Yeah, I'm saying in general, you don't find a lot of Mono shops. They're all .NET shops, right? IIS. So our Python driver is the next up to that, and C++, we have a C++ driver that's actually a little bit before the Python driver. And that C++ driver is going to enable the Python compile driver, PHP, Ruby, and all the other ones that like to have that kind of compile magic. But hey, Java's our first choice, right? Hey. Did I mention that Cassandra is completely written in Java? Good thing I'm at the Java users group, not the Ruby users group. Because I get stuff thrown at me.
So what happens when GC kicks in?
Huh?
So what happens when GC kicks in?
You clean up your garbage. There's ways to get around that. What are you, a troll? Man, such a hard case. Yeah, so Java's really turned out to be the first class language for funny things. And that is true, right? Everyone's like, oh, Java will never be a server operating system, systems language, because it's a garbage collection. Hadoop, Couch, Derby, Cassandra. I mean, all these things are all written in Java now, right? So it's kind of funny. HBase. Not Membase, not Memcache.
Memcache.
Still written in C, right? Because that's the way to get it done. And Mongo. C++. They got their problems. Anyway, so I would encourage all of you to go try it out. We also have it on Maven Central. So if you want to, we have a blog article on DataStax. If you want to Mavenize, go out and grab a jar, drop it right in there. You can get the DataStax driver. If you want to download Cassandra, you can go to the DataStax website. We have our community edition, which is just Cassandra. We also have DataStax Enterprise, which is free to download, which includes Hadoop and Solr. You can use it all you want. The only time you need to pay us was when you go into your really cool production setup, but other than that, it's totally free to use. We have a ton of documentation on just basic Cassandra, also Hadoop, and also Solr, but now a lot more on our drivers. All the documentation is on datastax.com, and most importantly is please try it out and contribute. If you want to talk about Cassandra, we're on IRC. We're definitely on Jira, but come and play. We like newcomers. We love to talk about what we do. Clearly, that's fun. So, yeah.
Okay. On the language support, do you know if the wrappers for any of the other JVM languages?
You mean Scala?
Yeah, so.
I was thinking Clojure personally.
Actually, it's funny you should say that. Yes, actually, because we do a lot of Clojure ourselves. Our Op Center has a lot of Clojure. Mostly you can use the Java driver as is, but it's not full Clojure.
Right. It
So-
doesn't match always the same with like
Clojure's coming.
Ruby.
Yeah, I just don't have. I don't have a lot of what's up here going. The Clojure, Scala, JRuby, those are all pending. We're doing, and we've got so many languages to work with. Yeah. Actually, what's funny is the Ruby people are the most upset because Twitter has always maintained a Ruby Cassandra client, but they've been really bad about it lately. They haven't been keeping up very good, so we need to pick that up. I know, we gotta make Ruby people. Because Twitter's not really a Ruby shop as much anymore. They're pretty much a Java shop, Scala. So they're like, we gotta keep it up. Not really. Yeah.
So for those downloads that you mentioned, are they deployable pretty easily in virtual machines, or are there any gotchas there?
No, it's really easy to virtual machine. That's matter of fact, that's what I run on mine. I use VirtualBox quite a bit. And so I run a lot of VirtualBox. You can see I got a lot of DataStax, Cassandra, Solr. It's very nice. It runs really nice. So deployables, what you can do with it is you can run it with, we have a tarball, deb, and RPMs. We have those three. If you want to add our
RPMs
repo,
are cross distros?
yes.
Okay.
So we have OpenSUSE and RPMs, and we also have CentOS and Red Hat. We have Red Hat repos, so if you want to add that in and just do a yum update or yum install, and we have a dev repo if you want to do an apt-get install. Try to make it as easy as possible. And
It's easy.
yeah, it's the easy button. And then we have our drivers. It's all Mavenized. You should be writing code tonight. What are you doing here? There's no excuses anymore. And actually, that's how I got started with Cassandra. It's funny because I was speaking at a cloud conference, and I was talking to a guy that I knew there. His name is Adrian Cockcroft. This is before he became the Adrian Cockcroft at Netflix. And we were talking. We were both on the same panel, and he's like, "What's going on? What's happening?" I was like, "Oh, I got these scaling problems." He's like, we're trying out this new database." I'm like, "What is it?" Cassandra. "Oh, how is it?" "We're switching all our stuff over to it." I'm like, "Is that good?" "Well, give it a try." That night, I came home, downloaded the tarball at the Apache website, got it running in my environment. It was up way too late, but I was just like, "This is awesome." That was was my start. And I just was hooked after that. I was like, wow, this really works good. Now it's 0.7, 0.6, 0.7. Yeah. And it's that kind of stuff. This is what we all do, right? I mean, we are not sitting back, not doing anything. I mean, if we're in technology, you gotta be into this really cool stuff, the new stuff. And that's why I said I'm probably gonna see a few of you downloading this tonight. But feel free, totally free. Any more questions? Nope. 9 o'clock. No, I didn't even have it hooked up on power. Yeah, but I'm running an SSD on this one, so it's really power. Yeah.
Okay, well, thank you very much.
You're welcome.
Thank you for the pizza, and go ahead if there's any leftover pizza, you're welcome to take it home and clean up the place as you leave. Thank you very much again.